It feels like every time we turn on the news, there's another story about a massive storm, a wildfire, or a flood. Natural disasters are hitting harder and more often than ever. But what if we had a better way to see them coming? What if we could get ahead of the curve? Well, that's exactly what we're talking about today. How AI is completely revolutionizing the way we prepare for, respond to, and ultimately recover from these crises. Okay, let's get right into it. This isn't just a feeling we have. The data backs it up. The Center for Research on the Epidemiology of Disasters tracks this stuff, and what they found is pretty startling. In 2021 alone, they recorded 432 major catastrophic events. Now, to put that in perspective, the average for the years before that was around 357. That's a huge jump. It means communities all over the world are facing this growing threat. And when we talk about the impact, let's talk about money. Just look at that number. Over $252 billion. That was the economic cost of these disasters in just 1 year, 2021. And you got to remember, that's not just about damaged buildings. We're talking about businesses destroyed, jobs lost, entire infrastructures that have to be rebuilt from scratch. It's a staggering cost. So it really makes you wonder, right? Faced with this growing challenge, can technology give us an edge? Can it help us see what's on the horizon? And the answer is a resounding yes. It's not about just building stronger levees or higher seawalls anymore. The real game changer is about building smarter systems. And that's all thanks to a huge technological revolution that's happening right now. All right, so to really get how big of a deal this is, we first need to take a step back in time. Let's look at how things used to be done, the old, slow way of mapping our world. It really puts into perspective just how far we've come. I mean, check this out. This quote from Natural Resources Canada says it all. It took over a century to create the first complete set of topographical maps of Canada. Just let that sink in. 100 years. Why? Because it was all done by hand. Think about it, technicians painstakingly drawing every contour line, covering maybe a couple of square kilometers in an entire hour. It was this incredibly slow, almost artistic process. And here's the kicker. The process was so slow that by the time the maps were actually finished and published, the world had already changed. New roads were built, rivers changed course, cities grew. The maps were basically out of date the second they were printed. So they were great as a historical snapshot, but for preparing for a fast-moving crisis, almost useless. And this slide really breaks it down perfectly. On one side, you've got manual mapping. Slow, outdated by the time it's done, and needing tons of people. On the other side, Geo-AI. That's geospatial artificial intelligence. We're talking hours or days, not months or years. We're talking real-time updates. It's like we've gone from looking at an old, faded photograph of the world to watching a live, high-definition video feed. So what's the magic behind this transformation? That brings us to the AI-powered revolution. And it's not just about one single invention, it's about a whole new toolkit, a powerful combination of technologies working together. Okay, the foundation of all of this is something called GIS, or Geographic Information Systems. The easiest way to think about it is like a smart map. It's a digital canvas where we can stack layers of different information. So you can layer on where people live, where the power lines are, where the flood zones are, all on one map. It lets you literally see the trouble spots. Next up, you've got remote sensing. This is basically our eyes in the sky. We're talking satellites, airplanes, drones, anything that can gather data from a distance. So say a huge hurricane just passed through. Instead of sending people into a dangerous flooded area, we can use satellite images to see exactly which neighborhoods are underwater. It's faster and way, way safer. And then comes the real powerhouse, artificial intelligence. If GIS is the canvas and remote sensing is the eyes, then AI is the brain. We are collecting a mind-boggling amount of data from all these sources. It's way too much for any human to sift through quickly. But an AI, it can chew through thousands of satellite images in minutes, automatically spotting things like damaged roofs or washed-out roads. A job that would take a team of people weeks, done in the blink of an eye. So when you put it all together, the modern toolkit is just incredible. We've got drones giving us close-up views. We've got satellite imagery from above. We have tiny little IoT sensors out in the world measuring things like river levels in real time. We're even pulling in data from social media, people posting pictures of flooding on their street. All of this information gets poured into big data analytics and machine learning models to give us the most complete, up-to-the-second picture of what's happening. And the result of all this?
Speed. We're talking about creating the data for these maps up to 1,000 times faster than the old way. Let me say that again, 1,000 times faster. A task that used to take an entire hour for a map maker can now be done in about 30 seconds. It's a completely different league.
Okay, so we have all this incredible speed and power. But what does that actually mean when a disaster is bearing down on a city? Well, it means we can finally stop just reacting and start being proactive. Let's dig into what that impact looks like. This right here is the single biggest change. For centuries, disaster management was all about reaction. The hurricane hits, then we clean up. The earthquake happens, then we rescue people. But now, this technology lets us get out in front of it. We can predict where the worst damage will be and take action before it happens. It's the difference between being a cleanup crew and being a city's bodyguard. One of the coolest tools making this possible is something called a digital twin. And it's pretty much exactly what it sounds like. Imagine creating a perfect, virtual replica of an entire city inside a computer. Every building, every road, every power line, every hospital. It's like SimCity, but for real-world disaster planning. So here's how it works. First, you build the super detailed virtual model of your city. Then, you break it. You throw a virtual Category 5 hurricane at it. You simulate a massive earthquake. The computer model shows you exactly what would happen, which bridges would fail, which power grids would go down, which hospitals would be cut off. It identifies all the weak spots so that you can go back into the real world and strengthen them before the real disaster ever strikes. Now, what about when a disaster is actually happening? This tech gives emergency responders what they call real-time situational awareness. So picture the Emergency Operations Center. A hurricane is making landfall. On the big screens, AI algorithms are analyzing live feeds from satellites and drones, instantly highlighting the hardest hit areas. It's looking at traffic data and mapping out the fastest, safest evacuation routes for people, and it's telling commanders the most efficient places to send first responders and supplies. It's a live, intelligent dashboard for saving lives. So, where is all of this heading? Let's talk about the future of preparedness and what this all means for building safer, smarter communities. So let's boil it all down. Why does all of this tech matter so much? First, we get faster predictions. Early warnings give people more time to evacuate, and that saves lives. Simple as that. Second, we get a much more optimized response. AI helps get the right help to the right people at the right time. And third, we get a smarter recovery. By quickly assessing the damage, we can help communities rebuild faster and, more importantly, stronger than before. You know, the biggest takeaway for me is that our whole idea of disaster management is shifting. The real work doesn't start when the sirens go off. It starts long, long before that. It's in the planning, the modeling, the simulations. True preparedness, true resilience is built in the quiet months and years before the storm. And all of this incredible technology leaves us with one last, really important question to think about. As we build these powerful AI systems that can see and analyze our world in such detail, we have to ask ourselves, how do we make sure this protection is for everyone? How do we ensure that the benefits of this technology reach every community, especially the ones who need it most? That's the challenge and the responsibility that comes with all this power.